friends, welcome back to the next lecture on NMT planning, as well as in this lecture we are going to take you to the next step in the 5-step planning process, where we will be looking at how to invest in NMT systems. Right? We have looked at how to plan and design. In the planning and design steps, we have looked at different criteria, selection criteria for the in the previous lecture. Now, we are going to look at how do you invest in an NMT system, and when you are trying to invest in an NMT system, you have to be picking the best alternatives from the point of view of net present worth or benefit cost analysis or economic analysis. Right? These are the 3 different techniques with which people usually identify which are the best projects to implement or to invest in. So, like we said, this is the 4th step in the 5-step process, and we are basically going to give you an idea about how to prioritize proposals for the city budget allocations. Right. In the previous lecture, we looked at scoring methods which will allow you to prioritize for designing and planning. Now, for investing and putting having the money in the city budget, how do you prioritize these projects? And then we will quickly look at how to identify alternative financing solutions, incentivizing private investment, and also developing a budget for rehabilitation and maintenance, which is very important, because what we are building we have to maintain as well. So, now any NMT project will always involve costs and will have some direct and indirect benefits associated with it. Right. So, what are the costs? There will be costs of design, construction, etc. Right, and also there will be cost of operations and maintenance. So, there are usually 2 types of costs that have to be considered while you are looking to invest in an NMT proposal. Now, after the based on the NMT proposal, there are different types of benefits or impacts that it might have. It might have a social impact, it might have a economic impact, or it might have a environmental impact. Now, when you are trying to invest, it is always better and easy and transparent to convert all these impacts into monetary terms. Right. So, economic impact is easy to convert into monetary terms, because you can say that X amount of revenue will be generated as a result of this NMT proposal. So, it might be easy to find. However, social impact, how do you quantify social impact? Right. So, maybe visual quality of the area will increase. So, how do you quantify visual quality? Right? What happens? What is visual quality? So, we will look at that. Environmental impact. So, environmental impact is reduction in emissions. So, now emission reduction might have we can quantify how much carbon dioxide or carbon monoxide reduction is happening, but as a result of that reduction, what is it benefiting to cost wise or monetarily, how is it benefiting the users? So, maybe the health of the users is improving. As a result, the health costs are reducing. So, that may be a way to monetize the environmental impacts of a NMT proposal. So, when you are trying to invest in any of the proposals, this is how an overall structure of what to identify in that project. You have to identify 2 types of costs. You have to identify what are their benefits or impacts, convert them into monetary term, and then say if the project is economically feasible if the benefits outweigh the costs. Right. So, if the benefits monetarily are more than the cost that is involved in identifying the project, building the project, then you would say that this project is viable or economically feasible, and we are going to go ahead and invest in this project. Now, what are the different methods in which you will determine the viability or the feasibility, economic feasibility of a project, right. So, the basic principle in any economic analysis is to know that money today or money in hand is always, the value of money in hand today is always higher than the value of money tomorrow, right, because for the value of money tomorrow you are paying some interest. So, today's money in hand is always higher, the value of today's money in hand is always higher than money tomorrow. So, based on this, this is the basic principle on which the present worth or the net present worth is calculated of any project, right. So, if you have to invest money in an NMT project, that means you are wanting that whatever money you are investing today in that project, the returns that you will get from that project in the future is higher than the value of the money in the future, right. I can invest money and get some interest on that money from, if I put it in a bank, but instead of doing that, what I am doing is I am investing it in a NMT infrastructure. So, when I invest in NMT infrastructure, I still want some returns in the future, and those returns have to be of higher value than what I would get from a bank return, what a bank would give me in return. So, that is the primary consideration. So, what the present worth technique or the formula says is that if the facility incurs these costs over its service life, then what is the worth or value of that facility today, present worth. So, costs, there are incurring costs, there will be some initial cost, then there will be maintenance cost and so on and so forth for the entire lifespan of that project. So, if I build this, what is the present worth of that project, of that future money, right. So, the net present worth, when we say net, what do we subtract from it is that we see all the benefits that are quantified, right. We looked at different types of benefits and converted into monetary terms. So, all of those benefits minus all of those costs is the net present worth. So, if the net present worth is greater than 0, that means if the benefits are greater than the costs, then you would usually say that it is worth financing or investing in this NMT infrastructure project, right. So, the different terms involved here. So, all the benefits BN are all the benefits. So, the benefits would involve the revenue that is collected from these services, right, over the lifespan, and also the salvage value at the end of the service life. So, maybe an infrastructure, when it becomes old, you can when it is going to be sold it as junk, you still get some salvage value out of it. So, that is all the money that will come in from the as a result of the project, whereas you have to subtract some of the costs, ongoing costs, that is maintenance cost MN, operating cost and user cost UN, and all of this will be ongoing throughout the life of the project, whereas there will be one cost that has to be paid upfront for construction. So, that is also a negative cost, but that is only a one time cost, you do not have to do it over the span of the lifespan of the infrastructure. So, this is just shown on a diagram. So, if these are the years lifespan of the project, so maybe the lifespan of the project is 4 years or 4.5 or 5 years, then in year 0 or currently you have to invest some money for construction, then maybe your operating and maintenance costs goes on, whereas you start getting benefits also from year 1 and year 2 and year 3. So, hopefully these benefits, so this one hopefully is higher than this, right, or cumulatively they are higher than this. So, if you add this and NPW is greater than 0, then the project is economically viable. Okay. This diagram is usually called cash flow diagram. The other method in which people usually find out whether a project is or an NMT project is viable is called the benefit to cost ratio, right. Benefit to cost ratio again is very similar to or the terms are very similar to what we have already looked at. All the benefits divided by all the costs. If the ratio is greater than 1, then it is economically viable. Okay. So, now let us explain this using an example, so that it is helpful to you. There are 3 NMT alternatives. This was selected for to encourage people to use NMT, right. These are the same examples that were used in the last lecture as well. Streetscaping with proper footpaths, public bicycle sharing system, and a PBS integration with public transport. I guess the third one is different. Okay. Now, the transport planner has to select the best alternative based on increased safety and reduced emissions and improved health quality. So, now the criteria on which the transport planner has to select the best alternative are savings from accident, right, increased safety, savings from emissions, because of reduced emissions there are savings, and annual health savings as well. So, maybe reduced safety plus higher exercise because of good facilities are resulting in annual health savings. So, based on all these 3, how do you determine which is the most viable project? And it is also said that the economic life of the project considered to be is 10 years with an interest rate of 3%, right. So, all of these terms are already for simplicity sake, they are already converted into monetary terms. However, it will take some effort if you are doing it for the first time to convert health savings and emission savings into monetary terms. So, what we see here is there is always an upfront cost, right, of constructing these things, and then these are annual costs, right. So, these are annual over 10 years we have to calculate this. So, using this formula for NPW, we look at what is the net present worth of project A, right. So, project A has an initial cost, so which has to be subtracted. So, that is a negative 60,000. Then it has annual costs or annual benefits of 5,000 in the first one is 5,000 in annual savings, 3,000 in annual savings, annual health savings of 500, and maintenance cost of 1,500. So, the maintenance cost has to be then subtracted, right. So, the maintenance cost is subtracted, these are all added. This is for 10 years, n is equal to 0 to 10, and the interest rate here is 3%, right. So, if you do the math, then it comes out that the net present worth of this project A is coming out to be negative, right. The value is not that much of a of that much importance, but the sign is of importance here. So, it is coming out to be less than 0, which tells us that it may not be the most economically viable project, right. Remember from the previous class, if you are scoring these projects to find out the best alternative using the simple scoring method, then this rated very high, whereas now when you are trying to actually invest in this project, you are finding out that the net present worth of this project is negative. Similarly, if you do it for project B and project C, this should be C, what you will find out is that project B has the highest net positive net present worth. Both of them are viable, both of them are in the positive, but once both of them are in the positive, which is the higher one? It is the project B. So, you can select project B for investment purposes. So, you would be confident that if I implement project B, I would get maximum returns on my investment. Similarly, for the same problem, if you use the benefit to cost ratio, you would see that project A has a benefit to cost ratio of 0.99, which is again less than 1. Project B has a benefit to cost ratio of 2.13. The terms are all very similar that we have already used, which is greater than 1, and project C also has a benefit to cost ratio of greater than 1. So, it tells you again this project A is not economically feasible, whereas both of these projects are economically feasible. However, this is more feasible because 2.1 is greater than 1.0. Okay. So, using both of these methods, net present worth as well as benefit to cost ratio, we are finding out that project B is the most viable project, economically feasible project. Now, the other method of finding out which is the best feasible project is to look at it from the point of view of purely the users. Okay. So, from the point of view of the users and their user benefits, you can determine which of the projects is economically viable. So, in order to do that, there is a concept called consumer surplus, which determines the economic benefits of economic benefits to current users. What it says is that if you have cost per trip on y axis and trips per unit time on x axis, then you say that if the cost is high, then very few trips will take place, whereas if the cost of a transportation facility decreases, the number of trips will increase. Number of trips is nothing but the number of people who will avail those NMT services, right. More number of people use facility, then there are more number of trips. So, if the price is high, then very few people will use it. If the price gets down, if the price decreases, the number of people using it will increase. So, your travel demand curve is an inverse curve, but for simplicity's sake it is shown as a straight line. It is usually not a straight line. So, for demonstrating this simple example, we are showing it as a straight line. So, what it says is this, what is this consumer surplus concept says that the total cost generated from a facility, right, total cost generated or revenue generated from a facility with a price P1, and demand of V1 right, is demand of P1 is equal to P1 times V1 or nothing but the area P1 D1 V1 O, right, O P1 D1 V1. So, this area, if you can calculate the area in that graph, it will tell you how much cost this facility can generate, right, how much revenue it can generate. Whereas, you can also find out, you can also know how many people are actually willing to pay for this service, right. So, some people may not be willing to pay. So, what is willingness to pay is some people pay out of compulsion, whereas some people are actually happily willing to pay for this service, right. So, the amount V1, so these are the number of people, right, trips meaning again number of people making these trips. So, the amount of people who are willing, so amount V1 are actually willing to pay is equal to the area, this big area, right, that is the area that V1 people are willing to pay. So, the area is O D D1 V1. So, this is the area that they are willing to pay. Now, if a project is economically beneficial to the users, right, how do you determine that economic benefit? That is determined by what is called the consumer surplus. So, that consumer surplus is this yellow shaded area right there. So, all you have to do is you know the entire area, you know the revenues generated or cost. So, the revenue generated essentially is cost minus the revenue generated. So, the net. So, if you subtract this square or rectangle from this trapezoid, you will get the triangle, and that triangle is the consumer surplus, which represents the economic benefit to the current users of that facility. So, if there is So, you can quantify the economic benefits of that particular NMT facility. So, that area is again it is given as the entire area OD D1 V1 minus this area OP1 D1 V1, right, minus this area will give you this consumer surplus, this upper triangle, which is P1D D1, P1D D1. Okay. Now, the next thing is to know what are the benefits to the users when the cost is reduced from P1 to P2 and demand increases. What happens is sometimes of an existing facility you may not have enough users. There is an existing bicycle lane, but to avail that bicycle lane you have to maybe use the public bicycle sharing system, which costs a certain amount of money, and hence you are seeing that you have put up these lanes, but nobody is using these lanes and nobody is using the public bicycle sharing system because of the price. So, in order to improve or increase the demand or increase the number of people using these trips, so that you get revenue out of it, right, you actually reduce the price of that price for the user. So, when you reduce the price for the user, how does the benefits change and how do you quantify those benefits? So, what it tells again step by step, if you say that if P1 decreased to P2, total cost generated from the facility with demand V2. So, now the demand, so if P1 original price was P1, now it reduced to P2. For P2 the demand is V2, or no, demand as in the number of trips per unit time, the number of people using it is V2, right. So, now since the price has reduced, what is the new demand? It is P2 times V2, or the consumer surplus would be the triangle. Now, the consumer surplus was this triangle initially as we saw, now it will be this bigger triangle, right, P2 D D2. So, the consumer surplus has increased, that means the economic benefit has increased and maybe there will be more people using it. So, what happens to the net benefit of the project by decreasing the price from P1 to P2? It is consumer surplus of P1 minus the consumer surplus of P2, or it is the area P2 D D2 minus P1 D D1, which gives you this shaded area. Okay. So, this gray shaded area gives you the benefits to users when the cost is reduced from P1 to P2, the demand increases from D1 to D2. Okay. Now, this trapezoid again has a rectangle in it and also has a triangle in it. So, what does the rectangular area determine? It determines the reduction in total cost paid by the original travelers V1. Now, since the price is being reduced from P1 to P2, what happens is the original users, which are only V1, they are also going to pay less, whereas the new users, which are V2, which did not use the facility when the price was P1, they are now going to earn some consumer surplus, which are the new users. So, which is given by this triangle D1 C1 D2. So, again understand the benefits are both to the existing original travelers as well as to the new users. So, by reducing the price, you are not only benefiting the existing users, but also attracting new users, and they are getting a consumer surplus of this. Again, you just need to determine the area of these two in order to quantify how do you quantify the consumer surplus or quantify the economic benefit. So, this is a very simplistic way. Consumer surplus, otherwise as an economic theory you can have classes on it for hours, but this is a very simplistic way of telling you how to determine economic feasibility of any project. In this case, we are looking at NMT projects, and from the point of view of user benefits in this project. Okay. So, again as we did in the previous lecture, we are going to give you an example of how to calculate these economic benefits. Say a new public bicycle sharing system has the following demand curve, or an existing public bicycle system has the following demand curve. So, what it says is that if the price of the public bicycle sharing system is 20 rupees per kilometer, nobody is going to use it, right. There are no trips per hour, whereas if it reduces to 15, then you will have 50 trips per hour. If it reduces to 10, there will be 100 trips per hour, and if you reduces to 5, there are 200, and so on and so forth. So, this again it is a simplistic linear curve, but usually demand curves are not linear. So, what can we determine? A, can we determine the consumer surplus when the fare is fixed at 10 rupees per kilometer? B, what is the net benefit by decreasing the fare from 10 to 5? What is the net benefit? And what is the consumer surplus earned by decreasing the fare from 10 to 5? So, what is the net benefit by decreasing, and what is the consumer surplus by decreasing? So, let us look at the first one, which is the consumer surplus when the fare is 10 rupees per kilometer. So, when it is 10 rupees per kilometer, we already saw that the consumer surplus is the area of that triangle. So, the area of the triangle is 0.5 as in 1 by 2 times 100 times 10, right. So, it is 500 rupees per kilometer is the consumer surplus or the economic benefit to the users, right, or the economic benefit as a result of users using this system. Okay, it is an economic benefit. So, 500 rupees per kilometer. So, if you have a bicycle sharing system for a network which has 20 kilometer network. So, every kilometer you are getting a benefit of 500 rupees when there are 100 trips per hour at the cost of 10 rupees per kilometer. Next is, what is the net benefit for decreasing the fare from 10 rupees to 5 rupees. So, net benefit is the entire trapezoid between 10 and 5 and till 150, because at 150 at 5 rupees there are 150 trips per hour. So, area of the trapezoid, again if you just calculate the area of the trapezoid. So, you see that there is a net benefit of 625 rupees per kilometer if you reduce the price from 10 to 5. So, net benefit also includes all the costs that are usually associated in construction, in maintenance, in operating. Usually we think that by reducing the cost or reducing the price, we may not be able to cover for operating or maintenance costs, but if you calculate it properly, you are actually benefiting more, which that benefit can be again put back into the maintenance and operating costs. Finally, what is the consumer surplus earned by decreasing the fare? So, the consumer surplus earned is the consumer surplus for the new users, right. Already the existing users have the consumer surplus, but the new users now have this additional consumer surplus, which is the triangular area, again 1 by 2 times 50 times 5, right. So, that is the new consumer surplus that is earned. Simple enough. This method, this consumer surplus method, allows you to identify or allows you to quantify in a very simplistic term what are the economic benefits from implementing any kind of project. Finally, let us look at briefly look at the other 3 steps that are involved in the 4th step of 5-step process, which is InVEST. We have looked at prioritizing NMT proposals. The other this next step in it is the finding of alternative financing sources. It is as we had mentioned before, money for NMT projects are always lumped with other projects, other highway projects or other mass rapid transit projects. So, you have to always be ready to find alternative ways of financing your sources, financing your NMT projects. So, one options currently that are being explored are called as green financing options, or saying that polluter pays, the concept of polluter pays, right. So, if you have vehicles, you need to be taxed more, or if you have if you want to park your motorized vehicle, you need to pay higher parking fee. So, those all work on the principle that the person who is polluting the environment is paying more, right. So, that are called greener financing options. The next thing to look at is developing incentive for private investment, right. Should not always depend upon public money to come in, right. Although these are all public infrastructure, but private investment is very essential in these cases, and they can be done by small things, but they all accumulate up into the larger network. For example, if you just amend some of the building bylaws and make it mandatory to have active frontage along the front of your building, that means active frontage meaning active facilities, active meaning bicycle tracks or sidewalks or whatever. So, when you are having a frontage on a main road or a collector road or something like that, you have to have a footpath in front of it or a bicycle track in front of it. Similarly, if you have a commercial building coming up, you have to have a sidewalk in front of your shop, or so on and so forth. So, that and that is a private investment. The builder who is building it or the shop owner who owns the shop needs to take care of the frontage of their shop or building. Finally, the last thing to remember while you are investing is to also have some budget allocations for maintenance and rehabilitation, right. It is not only important to build new facilities, build new NMT facilities, but also to rehabilitate them from time to time and also maintain them from time period to time period. So, it is all, in order to do that, in order to have a budget, you always have to maintain inventory of your NMT systems. You have to always have some periodic condition checks of your inventory. You have to have a plan, right. So, this you have to know that the sidewalk will last for n number of years, a street light will last for y number of years. So, you have to know, if you know the life cycle, then you can have a plan for when to rehabilitate and when to replace them. And also you have to have a specialized team, right. You cannot ask the designer or the construction person to rehabilitate and maintain, right. So, you have to have your own team that will allow you to monitor the performance of your infrastructure, and you can have a budget that is performance based for maintenance and rehabilitation. So, that concludes our this lecture where we have looked at different ways of financing NMT infrastructure, and how do you invest, how do you quantify or prioritize your investment priorities. Again, the guidance documents are given here, and we have exposed you to two different types of methods to determine financial feasibility and economic benefit analysis, net present worth benefit cost analysis, as well as consumer surplus. Thank you.